Hello and welcome. You join us live at the Guiana Space Centre for the 6th launch this year. And there's Ariane on the pad going through the final preparations. Liftoff is scheduled in just over 12 minutes' time. You can see the countdown there on the top right-hand side of your screen. I'm Katie Haswell, and our interpreters, Diane Borelli and Christopher Jack, are translating me for our French-speaking viewers. Ariane 5 is a big and powerful beast, and she's made of 3 sections. We call them stages. The first stage constitutes the 2 boosters. There they are on each side, strapped onto the main stage, the large tank in the centre. Above it, we have the upper stage, and above that is the fairing. There it is, a height of 17 metres tall. And inside we can see we have our 2 satellites. In the upper position we have Star 1C4 for Embratel Star 1. It's a telecom satellite. And below it is MSG-4 for EUMETSAT. It's a 2-ton satellite. And they are both waiting patiently in there, getting ready for liftoff. This is mission control. It's about 18 kilometres from that pad. Various teams working in here. The parts of Ariane 5 arrived at the port in Kourou after an 11-day journey from Europe and were transported to the launcher integration building for assembly. The boosters were transferred from storage and attached to the main stage. The upper stage was then integrated with the vehicle equipment bay containing the onboard computer before the whole thing was transferred to the final assembly building on June the 16th. Meanwhile, a few kilometres away, MSG-4 and Star 1C4 underwent their own preparations in the clean and secure environment of the dedicated satellite facilities here at the Guiana Space Centre, where teams performed a number of operations, including filling the tanks with propellant. Once transferred to the final assembly building, operations could begin to install the satellites in the launcher using special attachment systems. The whole thing was encapsulated inside the protective environment of the fairing to form what is known as the upper composite. The day before launch, the whole ensemble was rolled out to the pad along a dedicated track, all fully integrated on the launch table with the umbilical tower and supply systems, ready to undergo the final preparations. Well, that was 2 days ago. This is today. And you can see on the right-hand side of the screen there what we call the status panels. A little bit like the dashboard in your car. These are all the main systems across the base which send their health status here to these boards, which are in mission control. And just like traffic lights, they all need to be green for a launch to go ahead. And right now, that is indeed the case.
À tous de DDO, attention pour moins 1 minute. Top H0 moins 1 minute.
We are live at the Guiana Space Centre for the launch of Star 1C4, a telecommunications satellite for Embratel Star 1 and built by Space Systems Loral, and the weather satellite MSG-4 for EUMETSAT, built by Thales Alenia Space. Our very best wishes to all the teams. Good luck, everyone.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité. Top allumage moteur Vulcain. Allumage confirmé. Top. Allumage AP, décollage. Les paramètres à bord sont nominaux.
And there she goes, blazing her trail across the equatorial skies, tucked behind a cloud there because it was very beautiful skies earlier today, and then the clouds came in. And after the initial 12 seconds of vertical climb, we rotated to the east, and now we're heading out over the Atlantic Ocean. We are burning 3 engines. You can see the blue flame is from the Vulcan engine,
Passage
which
du
we...
lanceur en vol supersonique, les paramètres à bord sont normaux.
Yeah, we're going supersonic. We've 48 seconds into the flight. We went through Mach 1, and that means that we're now travelling faster than the speed of sound. We're actually getting the rumble of the vehicle as she flies over here at the Jupiter Mission Control Center, about 18 kilometers from that pad. So, yeah, I was saying we're burning 3 engines, but it's those 2 boosters on the those great big tanks there on the side of the vehicle which are doing all the work, and their job is to get us away from the gravity of the Earth, gravity which makes life possible for us here on Earth, but it also makes it very difficult for us to get away. And we need a lot of firepower to do that. On the bottom of the screen, you can see our altitude. There
Les paramètres
is...
à bord sont normaux.
He's telling us that everything's going according to plan. We can see there the altitude is 51 kilometers kilometers above the Earth. In the middle, our distance from the pad, 71 kilometers, as if we were to draw a line across the Earth. And our speed, 2 kilometers per second. And we are getting the scheduled losing of the boosters.
Séparation des EAP, les ensembles d'accélérateurs à poudre.
And he's confirmed it. Separation of the boosters is confirmed. They have burnt their propellant and we don't need them anymore. We are shedding weight. The lighter we are, the faster we go. So we're now burning the main stage. That great big tank there, the grey tank of cryogenic propellant. That's burning for about 9 minutes. Take a look at the top of the vehicle there, you could see it. That was the fairing there on the right-hand side. That's the pointed nose of our launcher. It's protecting the satellites from the rigours of the launch. The acoustic vibrations at liftoff, notably. I think you can imagine just how loud.
Les données reçues sont conformes à l'attendu. Le vol est nominal.
He's saying that everything is nominal. That means that everything is normal and everything is going according to plan. And the fairing is also protecting the satellites from friction because we're flying through the dense part of the atmosphere. And of course that warms the skin of the launcher. But right now we're coming to the edge of that dense part. Look at our altitude, 120 odd kilometers above the Earth.
Séparation de la coiffe.
And we've had separation of the fairing. We don't need it anymore. We're losing weight again. And look at how those parts flex there as they fall. It's called the breathing mode, and it's all part of the plan. It's an incredible thing to think that it takes us just over 3 minutes to climb outside Earth's atmosphere and get to the edge of space. That is all that protects us from the cosmos and from space. Makes you realise that we really do need to look after our atmosphere. If you were driving your car on a vertical highway into the sky, it would take you about 50 minutes. So, our satellites are now exposed to space for the first time.
Les mesures sont correctes. Le fonctionnement du lanceur est conforme à l'attendu.
Everything's going normally. You can see there on the picture on the right, Star 1 is the satellite at the front. We can't see MSG-4 behind it because it's covered by the black structure which we call the cylinder. And you can see there, Star 1, The rectangular structures are the solar panels. So that's the tracking station there, Galileo, you can see. The first tracking station, that's at the Guyana Space Center. That's tracking our vehicle at the moment. Our altitude, 163 kilometers above the Earth. We are 528 kilometers from the pad along the ground, and we're flying at 3.29 kilometers per
Les paramètres
second.
de propulsion et de pilotage sont normaux, le vol est calme.
Everything's going according to plan and the flight is calm, says our range operations manager. And we launched 5 minutes and 50 seconds ago from the pad here in French Guyana. And here we are. You can see Star 1 C4 at the front there. Those two round structures are the reflectors, and in the middle, so to the left if you like, of Star 1 C4 is that black structure, and that is called the cylinder.
Tous les paramètres à bord sont nominaux, la trajectoire est normale.
There we go, 6.5 minutes ago. So the cylinder, the black structure, allows us to launch 2 satellites at the same time on board Ariane 5. And to the left of that you can see, well, the disc, the grey disc is
Le pilotage est calme, il reste moins de 2 minutes de propulsion du premier étage.
Is the upper stage. He's telling us that everything is calm and we have 2 minutes left of propulsion on the upper stage. So we're heading out across the Atlantic, and our flight path takes us along the equator across Africa, and we'll start separating the satellites over the east coast of Africa. It's going to take us about 20 minutes to get there before we separate the first satellite, Star 1 C4. Right now we're at an altitude of 189 kilometers. We're going to have to travel to 1,145 kilometers above the Earth to separate Star 1 C4. We're tracking the launcher using ground stations as she flies over. It's called telemetry.
Il reste moins d'1 minute de propulsion de l'étage principal.
And Ariane sends data to those ground stations, which tells us how the flight is progressing.
Acquisition de la télévision lanceur par la station de NASA au Brésil.
How the flight is progressing in real time. And we have the acquisition of signal there confirmed at the Natal tracking station. That's on the northeast coast of Brazil. That's our second station to pick up the signal. We're looking at computer-generated images here. They're showing us what the experts have calculated is actually happening to the launcher and the satellites. Basically, the teams plan a very precise schedule of events, and they're all based on extremely accurate predictions. Everything's going according to plan, he says, and we have a couple of seconds left of propulsion. And now we can see there the upper stage has switched off its engine, and we now have switched on the engine of the upper stage. You can see it there, the blue flame on the left-hand side of the screen. These are images from a previous launch when we had cameras on board the launcher. So we're beginning the next phase of our journey. The upper stage has taken the wheel, and its job is to transport our satellites to their correct orbit so we can separate them. And the first one to be delivered will be Star 1 C4. Everybody at Arianespace is absolutely delighted to be orbiting another satellite for their friends at Embratel Star 1. They've been working together for many years, and Arianespace has launched all 10 of their satellites. These teams all know each other very, very well. And of course,
De
the
réception attendue
Olympics
de la télémesure lanceur
are
par la
going to be
station de
benefiting. So
Kourou
Embratel
gagné
Star One is one of South America's biggest operators, providing important services.
au pilotage est calme et les paramètres
Rodas.
lumineux.
Encurtam distâncias, aproximam pessoas, geram energia. Lâmpadas transformam a noite em dia, iluminam cidades, promovem encontros. Celulares conectam pessoas, propagam informação, trazem o universo para a palma da mão. Ideias nascem quando alguém se pergunta: e se? Ideias surgem quando alguém encara um desafio por um outro ângulo e decide explorar novas possibilidades. Imagine um mundo onde é possível acessar seus dados de qualquer lugar, onde sua informação é gerenciada de maneira segura e acessível, onde seus parceiros e clientes estão sempre ao alcance de um aperto de mãos, onde a tecnologia é usada para garantir desempenho e segurança para sua empresa. Agora, abra os olhos e entre na era da inovação. Com uma empresa capaz de reinventar a presença, redesenhar a nuvem, redefinir a mobilidade, reorganizar a informação e, mais do que nunca, multiplicar a criatividade. Porque lá, no início de tudo, nos algoritmos por trás dos programas e computadores, existe algo único, imaterial, frágil até, uma ideia. E uma ideia não é nada se não está acessível, se não é compartilhada. As ideias que mais circulam são as que revolucionam, reorganizam, renovam, transformam o impossível em realidade e colocam o mundo em movimento. Embratel Claro Empresas. Ideias que movem.
And during that film, we picked up the signal at the tracking station in Ascension Island, halfway across the Atlantic.
Les paramètres de propulsion et de pilotage sont normaux, le vol est calme.
We're halfway across the pond. And for our French-speaking viewers, I am being interpreted by our two interpreters, Christopher Jack and Diane Borelli. There's no question that Star 1C4 is a fantastic piece of technology. Space Systems Loral designed it and built it at their plant in Palo Alto. And the Loral and Ariane space teams are old friends. They've been working together for many years. Today is an important anniversary for them. It's the 50th Loral satellite that Arianespace has launched.
Acquisition de la télémesure lanceur par la station anglaise d'Ascension, à environ 2000 km à l'est des côtes de l'Amérique du Sud.
As a world leader in providing commercial communications satellites, SSL built the Star 1C4 satellite for Embratel Star 1 to meet growing demand for direct-to-home television in the Americas.
Star 1 is the lead satellite operator in Latin America. We are owned by Embratel, and Embratel is part of América Móvil Group. Star 1C4 will be the most important satellite for Star 1. With Star 1C4, we will concentrate all the DTH operations of América Móvil in Latin America.
The satellite uses the flight-proven SSL 1300 platform and benefits from SSL's strong heritage and focus on quality. It has 48 active Ku band transponders.
We are very proud of this project because in addition of covering Brazil, the Star 1C4 satellite will cover continental US, Mexico, Central America and South America. This is an important project because it will well position our company as a regional satellite operator.
First of all, I'd like to thank Embratel Star 1 for the confidence placed in SSL for the build of Star 1 C4 satellite.
Star 1 C4 is the first satellite that SSL has built for Embratel Star 1. And in 2013, SSL was awarded a second contract to build the Star 1 D1 satellite. That spacecraft is currently in production at SSL's facility in Palo Alto, California. Star 1C4 is also important to SSL because it is the 50th Arianespace launch of an SSL-built satellite. This represents a long and successful history between the companies, spanning over 3 decades.
The two teams, SSL and the Arianespace team, have been always working very well together, focus on quality and performance at all time. So I'd like to extend my gratitude to the Arianespace executive team and extend it to the whole team here in Kourou for this number 50 mission.
It is with deep appreciation that SSL extends its thanks to Embratel Star 1, to Arianespace, and to the many SSL employees who worked to make this satellite a success.
And our other passenger is the 11th satellite in the Meteosat family and the last one in the second generation, number 4. Arianespace has launched all of the Meteosats except the first one, which lifted off in 1977, and that was before Arianespace existed. The first and second generations of Meteosats supply essential data to European weather forecasters, and the third generation is under construction. And MSG-4 is important because not only does it supply meteorologists with immediate information about the weather now, it also helps them to identify hazardous weather phenomena. The Meteosat program is thanks to successful collaboration between the European Space Agency and EUMETSAT, which operates a fleet of satellites.
MSG-4 is the last of the second generation Meteosat satellites, the last in a series, and it is a satellite which will bring the gap with the next generation, Meteosat third generation. We launch it now because we have 2 aging satellites in orbit, which have by far exceeded their design lifetime, and we will store this satellite in orbit for it to be ready when we need it. And it has also a big advantage. It saves money because we do not have to store and de-store on ground. The satellite is ready. And it saves also risks because when you have an old satellite and you need to retest it, there are always risks. So first of all, today we were the customer of this launch service. We were the customer of Arianespace. But of course, our role is much broader than that. We have prepared the ground segment, prepared the teams to take over the satellite, to commission it, and we are ready now to take over the satellite from ISOC. It requires a lot of preparation, and then our scientific and technical teams are ready to assess the products of the satellite together with the user community to make sure it's ready for use. So the geostationary satellites like Meteosat second generation are vital for monitoring the fast evolution of high-impact weather.
Without any valuable information being on the west side of a continent, we are totally blind if there's no information over the ocean, of the weather was coming towards us. It's helping us with convective clouds, how did they develop, and also with fog situations, if the fog dissolving or not.
We have 2 MSG satellites in orbit, operated in different modes, but simultaneously. One is scanning only Europe, but every 5 minutes. Another one is scanning the full disk, so Europe, Africa, etc., but every 15 minutes. So it gives Europe the best possible information to detect what is happening and to release the warnings on high-impact weather. It provides also important information for forecasts for longer range, up to 10 days. MSG tracks clouds, the movement of clouds, and retrieves estimate of wind vectors.
We have developed certain algorithms for atmospheric motion vectors. We also track fire pixels in MSG data, and also fog and low clouds are being detected by an algorithm developed by our service.
These satellites save lives, so that's why it's so important that we have continuity of the service with MSG-4.
The problem with our work methodology is always that we are here to avoid damage. And the avoidance, how much damage can you avoid if you have a good forecast? That's not possible because you can't have a second run of experiment in which you allow the damage to appear. And then you don't have any estimate of the beneficial impact of your good forecast.
MSG is also very useful for climate. It's very simple to explain. We have already 35 years of climate data records, of Meteosat imagery across the 2 generations of satellites. And climatologists tell you we need 30 years. Climate is the statistics of whatever can happen over 30 years. We have 30 years. So this is why Meteosat is so important for climate monitoring.
And you can see, just to reiterate, on the top there, the grey discs are the upper stage with their engine now, its engine now switched off. The black structure is the cylinder, the part which enables the double launches. MSG-4 is underneath it. And to the right, we can see Star 1C4 and with its round reflectors and its rectangular solar panels. Every satellite has to be positioned into a different orbit, and so the upper stage, which is very clever, has to be able to twist and turn in any direction that we want. And to do that, it has 6 small thrusters. They give short bursts
Fin de
of
visibilité
cold
attendue du
gas.
lanceur par la station de Libreville au Gabon.
He's just saying that we've lost the signal there at Libreville in
Début de la mise en
Gabon.
rotation au profit de Star 1C4.
And we are in the rotation phase. We're getting close to the injection orbit. That's where we separate the first satellite, Star 1C4. Look at the altitude. We're at 1,103 kilometers. We need to get to 1,145. We're very close. Our speed there, just under 9 kilometers per second.
Séparation du satellite Star 1C4.
And we have separation of Star 1C4. Congratulations to everybody at Embratel Star 1 and everybody at Space Systems Loral and all the teams. The Olympic Games are in good hands. So Star 1C4 is now heading out on its journey to its orbital slot, which is 70 degrees west. That's up there in geostationary orbit.
Tous les paramètres à bord sont normaux. Les manœuvres d'orientation au profit de la séparation du SILDA, le système de lancement double Ariane, ont démarré.
And he's telling us that everything's going normally, and the next phase, which is to separate the SILDA. So Star 1C4 is heading out now on its journey. It has to go through a series of operations to switch on parts of the satellite and check its health. It's going to deploy its solar panels in about 3 hours time, and then in 2 days it will have the first
Séparation du SILDA, le système de lancement double Ariane.
of 5 burns. And we have confirmation there that the SILDA is separating, and we can see it. MSG-4 for the first time, the
Début de
cylindrical
la manœuvre
shape.
d'orientation au profit de MSG-4, la charge utile basse.
And there it is, revealed for the first time. The first one was launched in 1977, and here we are, 38 years later, transporting the 11th one into space. We've launched 10 of them, so it's an important day for everybody. Bit of history for you. Back in 1946, a group of scientists and soldiers in New Mexico saw something that nobody had ever seen before. The
Poursuite des
first
manœuvres
images,
d'orientation au profit de la séparation de MSG-4.
the first images of Earth from space. They put cameras on board a V2 missile and they launched it from the pad there in New Mexico. And from 65 miles above the Earth, they managed to see our planet from beyond our atmosphere. Very grainy black and white images they were. But observation on our planet really started with meteorology, and that was in 1960 when the first weather satellite was launched. It was called Tyros. And we got the first television picture of our Earth from space. That was grainy and black and white too. But can you imagine what it must have been like for people to see for the first time really properly the curvature of our planet? It had the image itself was not quite half the planet, but nearly. And although to us now it seems very simple and basic, it must have been incredible. For the first time, people really saw our planet as round. Tyros actually lasted only for 78 days, but it was important because it proved that satellites could be an incredibly useful tool for surveying global weather conditions from space and really telling us more about our planet. And that's where Earth observation really started. Of course, nowadays, we're all very, very used to seeing satellite images all the time, and in particular weather satellite images.
Tous les paramètres à bord sont toujours nominaux.
Everything's going normally. Of course, predicting the weather is far more important than simply deciding whether to take the family on the picnic. These kind of advanced satellites provide really important information for other applications as well. Things like hydrology, agriculture, environmental studies, and of course the meteosats are very useful for giving us information for risk prevention and disaster warnings. Just a reminder that these images we're looking at, these computer-generated images, are all exactly showing us exactly what's happening in space. So this information has been put into the computer by the experts and they've generated the images. So we're really watching what's happening. What you see is what you get. So the meteosats are very important for short-term forecasting, and it's often called
La phase d'orientation se poursuit nominalement.
It's often called nowcasting. They're giving us information about what's happening to the weather around our planet now. It's very important. It's kind of like watching a movie. You can see the clouds progressing, you can see the pressure, you can see the depressions. In fact, it's all those pictures that you see on the television. Every time you watch the weather forecast in Europe on the news, for example, you're looking at pictures from the meteosats. They're hugely important for meteorologists. I mean, the truth is they probably couldn't really function without them because it would be a little bit like closing the blinds and not being able to see outside. It's their window on the weather. So there are a couple of types of weather satellites. There are the short-term forecasting satellites like the Meteosat series. And then we have another type of satellite called METOP. And these guys are lower orbiting polar satellites. And the experts use those to make longer term forecasts. They actually probe the atmosphere and they make profiles, although you could say they're a little bit like the scientific barometer and thermometer in space. It's really important to understand the short-term forecasting because it's quite a challenge. It may not seem it,
La
but
phase d'orientation au profit des MSG-4 se poursuit nominalement.
Everything's going normally. It's quite a challenge for meteorologists to really understand if a storm develops, for example, what's going to happen next. So,
Fin de la manœuvre d'orientation.
and we're at the end of the orientation maneuvers.
Début de mise en rotation au
And
profit de
beginning
MSG-4.
of the rotating phase for MSG-4. MSG-4 is what we call a spinner. It means that it stabilizes itself simply by rotating on one axis. That's a little bit like a spinning top. And right now, we're spinning it up. We're getting ready to release it. The upper stage is going to start rotating it faster and faster until it gets to a spin rate of 30 degrees per second in order to separate correctly. Look, you can see it there, it's just starting to rotate. It's actually going to start spinning more and more once it's separated. It'll spin up to 55 revolutions per minute, and then tomorrow it'll fire its engine.
La vitesse de mise en rotation requise est atteinte.
It'll fire its engine for the first of 4 burns. So we've now reached the correct rotation speed. In 7 days' time, it's going to get to a rotation speed of 100 rotations per minute. And the reason is that it stabilizes it. And it gives us a much better image of the planet.
Et séparation MSG-4.
We have separation. Separation of MSG-4. The last of the second generation satellite series is on its way to its orbital slot, 70 degrees west. Congratulations to everybody. It's a big day and the culmination of many months' work for some, many years. Lots of happy faces there. A great feeling of a job well done. I think everyone can feel very proud of themselves. Everybody knows that they played a key part and they will be absolutely delighted with today's success.
Ladies and gentlemen, distinguished guests, I am delighted to announce that according to our onboard telemetry system, Star 1 C4 and MSG-4 were separated as planned on the targeted optimized geostationary transfer orbit. Our 80th Ariane 5 has just completed its 66th success in a row. Numbers are good and easy to remember tonight. 10th satellite launch for Embratel, 10th Meteosat satellite launch for EUMETSAT, 50th mission with SSL, et là, on va parler d'un vieux couple. I do not dare mentioning.
And we are going to talk about an old couple.
Second satellite with Thales Alenia Space. This is just great. In upper position, Star 1 C4 will provide a wide range of telecommunication services above the American continent. This satellite is a must in view of Rio 2016 Olympics. Let me take this opportunity to deeply thank Mr. Gustavo Silbert and Mr. Lincoln Oliveira with us tonight, representing Embratel as President and General Director, for being so faithful to Arianespace. Indeed, all Embratel Star 1 satellites have been launched by Arianespace so far. Since the very first one, it was with Brasilsat A1, successfully orbited from the Guyana Space Center 30 years ago. Going through the A, B, and C satellite series, our companies have definitely developed strong ties over the years, which will now perpetuate with the D generation, since Star 1 D1 also belongs to our order book for our launch next year. Congratulations to SSL as well. Star 1 C4 is the 50th geostationary spacecraft built upon an SSL bus to be launched by Arianespace. We have 14 more SSL satellites currently in our backlog to continue on the same successful path. So thanks to Paul Este for being with us tonight to celebrate this great partnership. MSG-4, the second passenger on this flight, is the last of a series of 4 second-generation geostationary satellites used by EUMETSAT for climate monitoring with a main focus on high-impact weather detection and forecast. Less than a month after Sentinel-2A launch by Vega in the frame of Copernicus, this is another European contribution to sustainable development in a key year to be concluded in Paris with the famous COP21. I want to express my gratitude to EUMETSAT for entrusting against Arianespace with this launch, and particularly to Alain Ratier, its president, who attended the launch from EUMETSAT's headquarters in Darmstadt with many invitees, and to Clémence Kayser, his representative here in Kourou with us tonight. Last but not least, congratulations to Thales Alenia Space, MSG manufacturer. As I have said, it is the 142nd satellite we orbit for Thales Alenia Space, and I must say that the first satellite we have orbited for Thales Alenia Space was already for EUMETSAT. It was in June 1981. Tonight, we are halfway in our 2015 roadmap. We have performed six launches already, in line with our busy manifest, targeting up to 12 launches in 2015. Arianespace is demonstrating, launch after launch, its capability to increase its operational pace while remaining the most reliable solution for all its customers. Tomorrow, we will inaugurate a new propellant loading facility dedicated to Soyuz upper stage. This new facility will add again to our flexibility and launch capacity, which we are pleased to offer to all our customers. As a conclusion, I want to thank all our partners. First, our industrial partners led by Airbus Safran Launchers for delivering this 80th Ariane 5 without deviating from the highest quality standards which have made its fame worldwide. Thanks to ESA member states for their unwavering support to the Ariane program. And I want to tell a warm welcome to Jan Werner, this launch being the first one under Jan's leadership as ESA DG. Thanks to our partner, the CNES CLG, for the outstanding availability of the spaceport and for our outstanding partnership. Thanks to our ground industrialists here in French Guiana, who have already started to prepare our next launch. And for sure, I want to thank all Arianespace teams for their full dedication to our launches and to our customers. This campaign has not been a parted campaign. It was a difficult campaign, but as always, Arianespace team have demonstrated launch after launch, year after year, that they make the difference with a new success. So I now leave the floor to our customers and partners. Thank you very much for your attention.
So it's mission accomplished once again for Arianespace and the 6th launch this year from the Guyana Space Centre. Congratulations to Arianespace's customers, Embratel Star 1 and to EUMETSAT, and of course to the manufacturing teams led by Space Systems Loral and Thales Alenia Space. Two satellites are now heading out on their journey to their final orbit. The best of luck to all the teams with the next phase of your operations. Thanks for joining us here live at the Guyana Space Centre, and from me, Katie Haswell, goodbye.
I wanna